Soon we are going to start discrete functions, and we'll talk about arithmetic series, geometric series, sequences and all those things. All these functions you'll note are discrete functions. Till now the functions which you did were continuous kind of functions, right? So discrete functions are not continuous. They have like points and they can be shown as scatter plot rather than a continuous graph, which you had been seeing in functions so far. So the major shift is when you move from functions to discrete functions. Let me put it here. When you are moving from functions to discrete functions, then the domain, which is normally x belongs to real numbers here, changes from x belongs to real numbers to x belongs to natural numbers. Now you can imagine if x is not continuous, is not all real numbers, then the graph will not be continuous, right? It will be a set of points which cannot be joined. And the value, I thought the problem will become simpler because you're not dealing with so many points, but in fact it complicates the whole thing. So we'll also see how it complicates. But before that, let me introduce you to this function, the floor function. It is like the ceiling function. It is a very beautiful function which will help us to solve many complicated problems. We'll also touch upon one such problem to give you the idea and to explain you why ultimately I am bombarding you with more difficult things. Well, there's one more thing to share here. You know, if there is a very difficult situation, the best way to deal with it is to make the situation more difficult. Then you'll think, well, the previous situation was better, not that difficult, right? So this is what we are doing. So already you're struggling with discrete functions, and here there are two new functions for you, which we call floor function and ceiling function. In this video, I'll talk about floor functions. So let me first tell you what a floor function does. Floor functions normally are like, if I have a value 2.3, then it rounds to lower value 2. If I have a value like say 2.7, that also rounds to 2. Even if it is 2.99, it will round to 2, right? So it takes away the integer value 2. So floor functions are also called integer functions, because the output of a floor function is always an integer, a discrete value, which will be like correlating function with your discrete function. Do you see that? Normal rounding, you see 2.5 is rounded up, right? And anything less than 2.5 will be rounded down as 2, right? But here, whether it is 2.1, 2.2 or 2.99, it gets rounded to the integer value 2, right? So that is what a floor function does. Literally, like in a room, anything in between ceiling to floor, right? It will get rounded, settled down on the floor. Anything will be settling down on the floor. That is how it is. And symbol is also kind of similar. So what we do is, the absolute function like this, it has got something like this. So that shows, well, we are interested in the lower value, right? So if we have any number x here, we take the lower value of that. That's the symbol. Some books may put 2 lines here, okay, and this. So that could be a symbol. For example, if I have a number like this, okay, this is not here, okay, let's put it like this, longer one, right? Let's say longer one, okay. Now if I write a value 4.9, then this is equal to what? This is a floor function. We are only taking the integer value, which is 4. So it is equals to 4. That is what floor function does. It actually picks up the integer value and leaves rest. Whatever is after decimal, floor function leaves that. So it brings down or rounds to the lower value, right, in integers. Therefore, it is also called integer function. So what it is doing is all real numbers, for example, between 4 and 5, all real numbers between 4 and 5, including 4, will be rounded to number 4, right? So on a graph, I can show this floor function like this. Say the value is 0 point something. Let's say this is my 1, this is 2, this is 3, 4, like this, and here we have 1, 2, 3, 4, and that's my floor function. And let's say this is my floor function x, right? And here I have x. So floor function, note this line here means we are interested in the lower value, right? So if my value is 0.9 or up to 1, it will round to 0. Do you see that? So my function will be, let me draw in red, will be 0 up to here. Do you see that? Lower value. But as soon as it becomes 1, then the value will jump to 1. So I'll have 1 here filled up, and here I'll have a hole here. This is the floor function. So any value beyond 2, let's say 2.3, 2.3 will be rounded to 3, right? So we have here and up to 3, right? So here we'll have a hole, but so that becomes kind of a step function. You see that? Where this part, the left mode, is filled up and does not include the right part. So you fill to the lower integer. So here the value is, for example, 1.2, 1.3, 1.4, all will be rounded to 1. But as soon as it becomes 2, 2 gets rounded to 2 only, right? So we jump to this. Do you understand? So that is how the floor function works. Okay. Now let's take a scenario where I'll show you application of a floor function. Okay. So let me draw a big graph here. Let us say that there is a fish tank. Let's say there is a fish tank, and the capacity of fish tank is 50 liters. Okay, so let me draw this fish tank here. And we have to fill this tank with water, correct? So what we can do is we can bring a hose pipe, and let's say this is my hose pipe, right? And the speed with which it fills is, let us say, 5 liters per minute. Let's say this has a speed of 5 liters per minute. Correct? So with this speed it can fill water in the tank. Now if I fill the water directly into the tank, then with time this water will fill the whole tank, right? How much time will it take? 50 liters, and the rate is 5 liters per minute. So let's do the math. So we have 50 liters tank capacity divided by the rate at which we are filling. Rate is 5 liters per minute, right? So this is equal to 50 divided by 5 is 10, and the minute goes up. You say 10 minutes. So in 10 minutes, 50 liters of water can be filled up. That's so simple. So let's draw this graph. Let's say we have a graph like this, like this. Okay, and let's put some points here. And let's say at this time our tank is full. If it is full at this time, then how much capacity it had? 50. So there is 50 liters of water in the tank, right? Let's say this is the volume with time, right? In liters. The unit is liters. And here we have scaled time in minutes. Correct? So it took us 10 minutes to fill the whole tank. Correct? 10 minutes. We filled up the whole tank. Let me just make some scale here. 2, 4, 6, 8, 10. That's fairly good. So 50, we say 10, 20, 30, 40. Okay. So I'll make it slightly smaller. So we got 10, 20, 30, 40, and 50. Okay. So we have like this. So what we see here is that at any time, for example, here in 2 minutes, it will fill up 10, right? In 10 liters. In 10 minutes, it will fill up 50 liters of water. And with time, we know the function. And this is a function which we could write as Vt is equal to, let me write this function here. Let me write this in red as I've drawn it in red. We say volume in the fish tank is equals to 5 liters per minute. So with time, it'll be 5 times t. So if t is 10, it is 50, right? If t is 2, it is 10. If it is t 2, then it's 10. T is 4, 4 times 5, 20, like that, right? Okay, so let me write down here these time, 2, 4, 6, 8, and then 10. Similarly, 10, 20, 30, 40, and this is 50, and that's my volume. Correct. Now let's take another scenario. So this you see is a continuous graph, x belongs to all real numbers, and was such an easy equation. What is the volume in the tank at any instance of time? Well, the volume is 5 times t, right? Not square, 5 times t. That is our formula. Somebody may get confused, so let me write it. Vt is 5 times t. If t is 2.5, 2.5 times t. 5, right? So like that. So easy. Now let's assume that somehow we can't take the tank to the hose, or hose is too short that we can't bring the hose to the tank. In that case, what can we do? Then what we can do here is we can fill this water in some other container. And let's say we have a big container here, and let's say this is our container, and the capacity of this container is, let us say, 10 liters. So that's our container with 10 liter capacity. Huge, but not that big. Anyway, and we filled this 10 liter container with this water running at 5 liters per minute. Once it is full, we'll pour this water into the tank. Correct? So that is the scenario. So what happens is, as the time starts, right, from 0, then this container, the 10 liter container, gets filled up, and it takes time. It takes how much time? It is 5 liters is the rate. 10 liters will get filled in 2 minutes, right? 2 times 5 is 10. So in 2 minutes it gets filled up. As soon as it gets filled up, then I pour the water into my tank. So let us say this is my tank. Okay, let's say this is my tank. So for first 2 minutes I have 0 water in it, because the water is getting filled into this, right? Nothing goes into the tank. But at 2, when this water is full, I pour the water into the tank, and my tank gets first 2 liters of water when the time just crosses 2, right? So it says 2 equal to or greater than, and at this time, when I throw the water into the tank, my jug is empty, I can refill it, right? So I bring my jug back, and it gets again filled up. It takes 2 minutes to fill up. So from 2 to 4 minutes, my jug is getting filled up. As soon as it is 4 minutes, jug is full. So I pour the water back into the tank. So second time, when I do that, my tank will get 2 liters, or rather 10 more liters of, this is 2 jugs. I should have written 2 jugs or 10 liters. So let me write here, no jug, this is 2 jugs, and 2 jugs means 10 liters of water, right? So as soon 4 minutes pass, then I am able to pour in second jug of water, right? That means 20 liters, right? This was 1 jug. Now, so once my second jug is full, I pour it in, and I get second jug of water. That means 20 liters, correct? And then this jug is empty, so I bring it back and refill it. It takes another 2 minutes to refill. So until the 6 minutes pass, this is full, and then I bring it back and then pour the water into this third time. So that means I pour it to the third time, so we got 30 liters when the time is 6, and like this we continue, right? It becomes 8, and like this we continue. Okay, let me tell you this process again. What is happening here? We start by filling our 10 liter container at 0 time, and at this time our fish tank is empty. There's no water in it, right? So on the graph there is no water here. in the fish tank, but our container, which is 10-liter container, is getting filled. At the end of 2 minutes, we are able to fill the container full and we throw that water back here. So there is no water till 2 minutes. Do you see that? But at the end of 2 minutes, we throw first jug of water in the fish tank and tank gets 10 liters of water immediately. Do you see that 10 liters of water coming up? By the first jug. Now once I throw the water from my jug 10 liters into the fish tank, it is empty and so I can refill it. So I start refilling. Second time, this 10-liter container. During this time, fish tank has how much water? Only 10 liters is sitting there, right? It keeps on there. Once after 2 minutes, which is total time of 4 minutes, this jug is full, I am able to put second jug of water, that means second 10 liters, into the fish tank. So at this time, my fish tank gets 4 liters, 2 plus 2. But until this time, it was sitting here at 2. Do you see that? So after the second fill, I got 20 liters and then after the third fill, I will get 30 liters. Do you see that? Like this it goes. Do you see? So we get a step function. Do you see? And the quantity in the fish tank is 10, 20, 30, 40. Discrete values. So now what is my volume of water in the tank? How can I relate this volume of water in my tank with respect to time? So the answer you know is what? My volume is 0 and then it is 10 and then it is 20, then 30, then 40 and then 50, right? Now how do I relate this with time? And we also know it is 0 when the time is less than 2 but more than 0, and it is 10 when the time is between 2, then equal to 2, greater than equal to 2 and less than 4. But how do I write it as a function? That is a huge problem. Either I can write as a piecewise function, right? I can make 6 pieces of this and say, well, if the time is between 0 and 2, then it is 0 liters. We say 0 liters, right? And if it is between 2, including 2 and 4, it is 10 liters. Well, that becomes a huge, right? Imagine if my fish tank is capacity of 5,000 liters, then what? I'll fill the whole page, right? Well, so now in such scenarios, see how the floor function works. The floor function says, well, I can help you out. And what you need to do is, you are doing times in sets of 2's, right? So if you divide time by 2, then what happens? If I divide t, this 2 by 2, I get 1. That means 1 jug, 10 liters. 4 by 2, 2. 2 jugs, 20 liters. Do you see that? So we get our function. So we can say, well, our capacity of each jug is 10 liters, right? So it should be 10 times the floor function. And the floor function for us becomes, this says lower integer, right? T divided by 2. Now see if it works or not. Let us say that 5 minutes have passed. If 5 minutes have passed, 5 divided by 2 is 2.5, which will, integer function will give us only 2. And 2 times 10 is 20. We get our answer. Do you see that? Correct? If the time is, let us say 7.8. 7.8 divided by 2 will be how much? 3.9. Correct? 3.9 will also round to 3 and we get 30 liters of water. Do you see that? So that is how the floor function works, and it converts our linear function into a step function. Do you see that step function? This is a step function. And how is it different from the ceiling function? That is another question which you should answer after going through both the videos. We will notice in floor function, we are including the lower point, not the higher. In ceiling, we include the higher, not the lower, because everything rounds up in ceiling, and here everything rounds down. Correct? So I hope you understand floor function, you understand its application, and you can now connect floor function with discrete functions. It is a machine which can convert real numbers to natural numbers, as you can see here, right? It was a real line. There's 0, 1, 2, 3, 4. It was like going continuously up to 50 liters, which we broke it down to 0, 10, 20, 30, 40, 50 with the help of this divisor, right? You see? We divided into packets of 10 each and got our function. That is how we could and we can relate real things, real numbers to natural numbers by using floor function. Look into the video on ceiling functions and see how we do convert real numbers into natural numbers. I hope you enjoyed, and this will give you a good foundation to do well in geometric and arithmetic sequences and series. Have a good time. Thanks. Bye.